Hello friends, welcome to the screencast. We are about to continue our search functionality journey, and in this episode we're going to work on contract tests. So without further ado, let's jump straight into the code and see how we're going to do that. And the best idea is to start off by running the acceptance test, and that's going to tell us where to continue essentially. So it says that we have to continue with our in-memory search service. So let's go ahead and create a test for that one. Now I'll move that one on the other side, so I'm gonna have them next to each other. So the in-memory search service essentially is a fake, and it might sound weird to write tests for the fake, but in fact we are gonna leverage the fake in order to come up with contract tests, and then later on we are gonna use the contract tests to cover, let's say, a real implementation. And when I say real here, I mean like implementation that's going to be a shipping code, let's say a search service that might reach out to an HTTPS repository and so on. So I'll go ahead and write a test here, and I'll start with, let's say, return empty result. So I want to make sure that an empty list of, well, I think it's going to infer the type. Empty list is returned when I call search service dot search, passing there an item, and then the search service is gonna be an in-memory search service. So it is not inferring the type, string, something like this. Let's run. And I think it's gonna fail because it's not implemented. And if I return here an empty list and run, it should work. Yeah. So let's first check this in. Let's say the in-memory search service. There is a typo. Search service returns an empty result set. Commit. I need here to be commit message. Yeah. Okay. Now let's do a little triangulation here. So I'll write another test that would say return values containing the query. So I want to make sure that a list of, let's say, item 1, item 2, and item 3 are returned as a result. And the result's going to be a call to the search repository, passing there an item. So the item is contained in all of these three. And the search repository is going to be a in-memory search. Why repository? It should be search service. Yeah. So yeah, if I run this, it's not going to work because the search service here is empty, but I want to pass there a list of, let's say, so I want to set up the in-memory search service to have, let's say, items more than what I expect here. And then I want to make sure that the filtering is happening. So let's say 1, item 1, then 2, then item 2, then item 3, and other. Doesn't really matter, but yeah. So let's add this as a parameter to the constructor. But here, what I'm gonna do is, let's make this val. The name's gonna be all items. The type is fine, and the default value, I'm not gonna put anything here, because if I put something here, the refactoring will replace all the calls to this constructor with what I'm gonna put here. So I just don't want to break anything that is already there. I'm gonna leave it empty, and I'll do the refactoring, and good. Now here on the right side, I'm taking, let's make it private, a list, and I'm gonna initialize it to an empty by default. So now, as we can see here, the first test that we came up with is still working, so the compilation works. And if I run, now I should have a failure for the right reason. So I am expecting these items to be returned. It's an empty list. Okay, and now how do I make that work is I do all items, filter, it contains the query. Here I can pass a flag here to ignore the case so that it's gonna return, it won't take in consideration the capital letters there. Right, so now it works. I'll check this in. I'll say the in memory search service uh, returns the matches. Okay, now I think I need the situation when I have a bad search. So let's say it throws a bad search exception. So it throws bad search exception when I call the search service, let's say with an empty query, and this is gonna be an in-memory search service. I'm not gonna pass anything. So in the previous episode, we came up with two exceptions that are sort of domain models, which is the bad search exception that's gonna happen. I was imagining that this exception is gonna cover situations when I pass, let's say, um, when the backend that I'm potentially going to call will reply to me an error which is like 400 up to 500. So in this case 403, I'm passing an empty query there, and it would reply 403, let's say. And then I have another exception, which is the out of internet exception. That's going to cover obviously situation when I'm out of internet. So let's say the real call might throw an IO exception. So why am I doing this? I might have modeled different types instead of exceptions, and um, that's something that's a decision that I came up at the moment, but it might be different. Uh, I mean, the model can be different. Doesn't necessarily need to be an exception. I just came up with it at that moment. But essentially, what I want to do is I want to draw a line here. Whatever I'm calling on the backend, if there is a backend, it might throw different exception. For example, an IO exception, whatever. I don't want to mess with such exceptions with my into my domain. In case something happens, for example, another exception is being thrown, I want to have this layer that's going to have to change and deal with different types of exception and translate those exceptions, or let's say if they were different models, if I had a model, it would translate the exception into the model that will represent the error on inside the domain. In this case, I have an exception, which is the either bad search or out of internet. It could have been different model, doesn't really matter. What matters is the this translation that I want to happen here. So let's go ahead and see if this fails for the right reason. And as I said previously, we have a validator, so an empty query shouldn't come here. But what we are trying to model here is the actual backend. What if, like, if we don't have the validator and we still pass an empty query, it would return something like 403. So that's the situation we want to mimic here. So it says, I'm expecting that search exception, nothing is thrown. Fair enough. Let's fix that. So here I would say if the query is blank, throw and out of a bad search exception. And now run. Let's see if that's gonna work. Of course. So now I'll do commit message would be the in-memory search service throws a bad search exception. And finally, let's cover the case when I'm offline. So throws an out of internet exception. And I would do assert throws out of internet exception when I call search service dot search query, and that's going to be an in-memory search service. Now, how do I mimic an offline search service? So I think I'm just going to pass null here, and I'll make this type here nullable. And just to prove if the test gonna fail for the right reason, I'm just gonna use the double exclamation mark there, and I would end up with potentially null pointer. So here it says I'm expecting an out of internet, but indeed it was a null pointer exception. So how do I fix that? I would do filter if it's not null, otherwise throw a out of internet exception. Now run. Cool. Let's check this in. The in-memory search service throws an out of internet exception. Cool. And now we can start working to extract contract tests. So this one here is gonna be, let's say, an offline search service. So that represents to me an offline search service. And the type should be a search service. And I would do a return here. It should be still green. So I just want to do a little bit bigger step in terms of making commits here. So I'll keep working on this extraction of functions. So this one here is going to be, let's say, all items, and then this one I'll extract, and I would say search service with all items, and maybe I can inline this one, search service with list of these ones. Yeah, I think now it reads better. Move it down there. I'll move, yeah, I want to keep them close to each other. So I have all items, and here I need the type to be a search service, which is important, and then return this. Should be still green. So again, I'm skipping a commit here. I want to make a bigger step a little bit. Now the last thing is this situation, but in fact, what I want to do is I want to make clear that I have an in-memory search service without item, and I'm searching for an item, so it returns an empty list. So how about extracting this into a search service without, and yes, I want to do that, and then I will pass here a list of item 1 and then item 2. Let's see the implementation. So without, I'll take here also a list of well, maybe, yeah, list of, sorry, all items, which is going to be a list of string, and it's going to be an empty list, and then it would return search service, and would do return in memory and then reverse item. So what I'm gonna do is I'm gonna uh, map all the items into, I'm gonna flip the strings that are coming in, and then I'm gonna pass into the in memory search service. So they are gonna be, I'm gonna have a search service without what is being passed. Now it should be fine. Cool. And now what I can do is I can extract a superclass out of this. I'm gonna extract it into a separate file, and I'm gonna name it search service contract. Now what's important is that I need all 4 tests there, and of course I'll need the functions to provide the search service with, without, or the offline one, but I need them to be abstract. So I'll do the refactoring, and that's what we end up with. So we have an in-memory search service test that derives from the contract test, and now it overrides the functions in the contract, and it provides a sort of type of search service that in this case is the in-memory search service. So we took the in-memory search service, we wrote tests for it, and from those tests we extracted a contract. Now, of course, by default, the in-memory search service accepts the contract. It works because the tests were working beforehand, but every other implementation that I might have for a search service will have to pass these tests. So essentially, I'm gonna write a test that will derive from the contract, and then I'll have to implement these functions and provide, make instance of what I'm gonna be implementing, let's say, remote search service. And I'll have to provide such instance, and it would have to pass all these tests. So that's how we are going to leverage the contract tests to make sure that implementation works well. Now, of course, here, I don't know why IntelliJ did not import automatically um, everything, but okay. So now if I run the search service contract, it's gonna run. If I have multiple implementations of this one, when I run, it will ask, for example, which ones to run, like whether all the implementations or only one. If you want it, let me know. I'm gonna record in the following episode. I'm gonna show how I would approach making a remote search service implementation and how I would use the contract test to make that work. Um, but yeah, I was not planning to include it in the scope of this episode, so I'm gonna have it as it is for now. So that's the contract, and here we have the in-memory search, which is essentially the same thing because it's the implementation of the contract. And now what's left is if we go back to our acceptance test and run it, it should tell us if we are done or not. And it fails, which means we have some implementation missing, which we do inside the search, in the searcher. Um, so what we need is, I'm gonna move this into a new function. I'm gonna call it, let's say, proceed search. So this is a search, and then if it's valid, proceed. And here we need to set the value of the live data to, let's say, show loading. Then we need a hide loading at the end. And then we also need this one. Of course, obviously this is going to work on the UI thread if we engage this one into a real application, and that's not what we want. But as well as with the remote, for example, implementation of the search service, I was not intended to include how I would do that in this episode. Again, if you want to see that, let me know. I'm gonna include that in the following episode. And what I would essentially do, I would, let's say, derive from a view model in the searcher, and then, or like create a custom scope or whatever, and then launch the repository search into a coroutine. So it's gonna do, I'm gonna offload from the main thread into a background thread. And now if I run the acceptance test, it fails because now the actual matches are not the same, which happens because the in-memory search service that we have here is empty. So if we add the items that we are expecting in the acceptance test, it should work. So we need something like, let's say, 1, then item 1, then this should be a list of, then 2, another item, then item 2, and then else, let's say. Okay, it works. So let's go ahead and check this in. Search feature implemented. So I think uh, it's about time to wrap this episode up. As I said previously, in the following episode, I want to make a short retrospective of what happened here throughout, like from the acceptance test all the way till the contract tests. Why I did some decisions, what might have been done differently, and so on. But essentially, I want to say a few words about, the state testing versus behavior testing, and so on. And more importantly, I was thinking about making it short, but if you want to see a demonstration of how I would do the remote search service implementation using the contract tests, and also if you want to include how I would inject the coroutines here, and how I would offload uh, all the searching uh, all the searching functionality into a background thread, please also let me know, so I will do that for the next episode as well. So after we do the next episode, which is going to be the retrospective, we are starting all over again with the same exercise, but doing the inside out approach. So I think that's going to be enough for this episode. Thank you so much for the time, and I'm going to catch you in the next one. Bye bye. Have a nice day.